What is my modulation? I think in the beginning only yesterday's class, like greeting card, putting in envelope, that particular thing, the greeting card is an information and envelope is called like a carrier, which will carry that information. So inserting greeting card in envelope and sealing that envelope, then transferring the envelope is called like a modulation. The same thing here. So what is a modulating signal? So baseband signal, message signal. So can you remember the communication system block diagram? From there, I'll bringing it here. Modulating message baseband. It is given so many names, audio signal. So what is the frequency of this? Will be 20 to 20 kilohertz. Oh, sorry, 20 hertz to 20 hertz to 20 kilohertz is what? The modulating signal, baseband signal, message signal, or audio signal. That one. Let me transmit directly this. I'll give it to audio amplifier. I'll not modulate it. Let me give it to antenna. And it will radiate. So to what distance? The EM wave will propagate here. Antenna, and there's a person singing and there's a mic. So here what do we get? We get that audio signal. And this will become EM, it'll propagate here. So let's see that. What about the distance covered? What is the size of antenna? This H means here size of the antenna, not height of the tower. The antenna size itself. I'm discussing about the antenna size itself. How all these things are related here. Okay, let's come for this one. What is this audio signal? 20 kilohertz. Let me take it. So what is the F equal to C by lambda? Lambda equal to C by F. Let me calculate the wavelength required. So this will be 3 into 10 to power of 8 and frequency is what? 20 into 10 to power of 3. So what is the lambda I'm getting? 1.5 into 10 to power of 4 meter. Convert this into kilometer. 150 kilometer or 15 kilometer. Lambda. Then what is the height of the antenna needed for transmission? We need antenna height, or in general antenna, height of antenna. Height of the antenna, which will be 1/4 of wavelength of wave. There's a general rule in designing of the antenna. So 1/4, 1/4 into 15 kilometer. This will become 3.75 kilometer. So this is the height needed. Can we construct such a physical, such an antenna? And can we maintain it? Not possible, no? So practically, not possible. So first thing is like, if the modulating signal is directly transferred, there's a basic idea. So first difficulty what we face is the height of the antenna, which is practically not at all possible. I think I wrote somewhere here, practically not possible. So there's a one first difficulty is what with the antenna we have seen. Agree this? So next again, the power of a audio wave, the power of audio wave. So you go back to the waves and so on, or we have discussed something, the expression for intensity, expression for the intensity. So the power of a wave is inversely proportional to square of wavelength. for EM wave, the power and wavelength are related. So how come this equation has come like this? From where wavelength? Intensity of EM wave of, so what is the epsilon naught ERMS square, no? And what is ERMS? ERMS is just E naught by 2. So from where the wavelength you are bringing, so power equal to rho omega square A square V by 2. Energy density formula, and look at the omega what you can write, pi f equal to then frequency equal to C by lambda or V by lambda. V by lambda square will come. If you write in terms of this one, of course, like this for mechanical wave. For non-mechanical wave, again, the same expression, we can derive it, but the density of the medium should not come. And 4 pi, so this, and what is A in place of A, this will come like this, A naught. So here it is inversely proportional to this one. So the wavelength, so therefore what will happen? So now you look at this one. Power of a wave is inversely proportional to square of wavelength. Okay, let's come for this. Low frequency waves will have low power. Will I agree this? This is a general idea. The low frequency waves will have high wavelength. High wavelength what happen? Will have less power. So lower frequency waves, low frequency waves will carry low power. Okay, how power is related to any use of power? I think greater the power, you go for ground wave propagation. I gave one example, no? Greater the power, what happen? More the range, and we have power is directly proportional to range, that one. Greater the power, more will be the distance traveled by the wave. Power of a wave is directly proportional to the distance coverage or the range in general 2 years. So because of this, what will happen? The audio frequency wave is having less power. So definitely, if you directly transmit what all the person singing know, so mic will convert that into electrical signal, will be amplified, given to antenna. It will not cover to large distance. So in general, how much? It may go up to 1 kilometer or 2 kilometer, but how much we needed? We needed a large distance to be covered, 40, 50, 60, for a few hundred kilometers. Therefore, if you directly transmit the audio signal or modulating signal, first thing, like a length of the antenna is a problem, practically not possible to construct. Next is the range or the propagation distance will be very low. This is the second problem, what we have encountered. Third one, power of a directly proportional. So therefore, what we can say that modulating signal cannot propagate for larger distances. This is the thing. Okay, third one, if every person radiates, so like this, I think we have stations, no, FM, like 88, 92, like that, 10 stations are there. Now, if every person sings, every person transmit their programs, then at a receiving end, what happen? We are going to, a person is going to hear, so there is station 1, station 2, station 3. Okay, there's a receiver. Then all there's a station 1, station 2. Okay, let this be news, this will be song, this will be music. From different stations, the signals are coming. Okay, this is some chit chat and this is some debate. Okay, this and okay, anything you can write it. Okay, 5 stations will put it. Okay, now programs from 5 stations are coming, and you switch on the radio set. Then what happens? Simultaneously, you are going to hear all these 5 stations, no? Because what is the frequency of all? 20 to 20 kilohertz. All are having same frequency. Then all 5 signals, if they enter into receiver, then simultaneously when you receive signals from all. How it is like if 5 persons come and talk simultaneously in front of you. Tell me like, so one person is reading newspaper, other is singing song, other is just playing music, other is doing some chit chat, and other is doing debate. If all 5 persons come and stand nearby you, and if they talk like this, one sings, other plays music, that one, tell me what will happen. I think you are going to run away from there, no? That's called a distortion. Distortion will occur. Distortion means what? As good as like noise, no? I used to shout in class, okay, don't make noise. The reason for you, it's a discussion, but for me, it's a noise. The reason for that, like that, if every student talks in a class, then the superposition of all the waves coming from the students, they'll undergo superposition and it will not become a some sort of like a very pleasant to hear. In fact, it become like a noise, as good as hearing a noise. That's why teacher will shout in class, okay, don't make noise, don't make noise, don't make noise. That's the reason. You can do one thing. Mobile you have, television you have. I think 4-5 mobiles are there, no? So play different songs in all 5 mobiles and try to hear it. As good as you are not hearing anything, or better say that you are hearing a very high noise and you want to run away from there. So this is called like a, what is the problem here? If all stations, station means radio stations. If all radio transmit the programs simultaneously at audio frequency, then interference of waves occur, and distortion of signal takes place, and reception of program will be very noisy. That's all, no? Better to switch off that radio set and be happy. Or better you sing on your own song, or take newspaper, read newspaper. But practically what happened? We do have stations, no? They're transmitting. Or shall we allot time? Morning 6 to 8. Okay, news channel. Then song after 8 to 10. Then 10 to 12 music. Then chit chat 12 to 2 o'clock. Then 2 to 4 debate. Then 4 to, shall we allot 2 hours? Is it like that? FM stations, are they allotted time? No? All 24 they're available. No? And all they transmit, all stations will transmit their signals and you can pick up whatever you want. So how come all are transmitting and still we are not getting what you were discussing? Because the programs are transmitted at different frequencies. And which frequency you tune it, only that particular signal you are going to receive it. So therefore, if all radio stations transmit their program simultaneously or at audio frequencies, what is the problem? There's the thing. So therefore, what I've done, frequency multiplexing should be done. To overcome this, different stations must broadcast the programs at different frequencies. Okay, shall we ask this person to talk at 2 kilohertz? We'll ask this person to sing at 6 kilohertz. We'll ask this music, okay, you generate at 10 kilohertz. You do chit chat only at 12 kilohertz. Okay, you do debate at only 18 kilohertz. Can we do like this? Is it possible? So what is the audio range? When you speak, what happens? The sound signals will range from 20 to 5 kilohertz. And you take music, no? It will range from almost 20 to 20 kilohertz, finish word. So no way of allotting frequencies like this, audio frequencies. We can't put a condition. Okay, shall I ask you to speak at 2 kilohertz, 2000 hertz only? Not possible, no? So therefore, there's a stupidity here. But you only said so like they should be allotted different station sets by some method called like a modulation. That will come there. Not don't ask them to speak at different frequencies. Let them speak naturally. Will radiate at higher frequency. This one. To overcome this, the different station must broadcast their programs at different frequencies. This is done using frequency multiplexing, called as frequency multiplexing. Different stations will be allotted different carrier frequency. There is another thing here. Okay, this is about the basic thing. So therefore, to minimize the size of antenna, what you should do, you should go for higher frequency. Can we ask this person to speak at 100 megahertz? Anybody in the world who can speak it more than 20 kilohertz? Not possible, no? Gone. So therefore, how to decrease size of antenna? Let him speak it low frequency only will radiate, because the size of it all depends upon what frequency you are radiating. So let me radiate the signal at higher frequencies. So to minimize the size of antenna, to have higher range and to give differentiation, different signal frequencies, we are going to go for modulation. This is called like a need for modulation. What is our topic discussion? The necessity for modulation. So to minimize the size of antenna, to increase the range, and to provide differentiation, different carrier frequency, I'm going to bring a call like a modulation. In that, first we are going to discuss the amplitude modulation. So first what is the amplitude modulation? The amplitude of carrier is varied in accordance with modulating signal. So what I'm going to do, a high frequency carrier wave will be there. So let me set up the background so that mathematics will be easy for you. Okay, there's a modulating signal. High frequency carrier. Look at the time period. From looking at the time period of signals on, you can feel, no, it's a high frequency signal. It should be perfect sine wave. Huh? So I'm giving the rough diagram. So this is called like a carrier. This is a modulating signal. Now, after modulation, how do the signal? The signal will appear like this. I'm going to test your trigonometrical skills. Let's see how you bring your mathematics. You look at the amplitude now, how it is varying. Is varying as that of modulating signal. No? Look at the envelope. What is envelope? The dotted line is called as envelope. Upper envelope, lower envelope. Earlier, the amplitude of carrier was constant. So now the amplitude of carrier, it is varying according to the modulating signal. So this is called like a amplitude modulated wave. All these are with respect to time. There's a high frequency carrier. There's a low frequency modulating signal. And what is this? There's an amplitude modulated wave. Now what you have to look at, anything happen to frequency? The frequency of these two are same. But look at the amplitude, earlier constant, now the amplitude, how did it vary? Is very as it of modulated. So now shall I say that simplest, you may get confused, I'll call this a information, or better say song. So shall I write only information? And what is this? This is like a carrier wave. And what is this? Like a information in carrier. How it is available? It is available as like a change in amplitude. Please do, you should take help of the English language here. There's a information, there's a carrier. How here information available? It is available in the form of change in amplitude. That's called like a amplitude modulation. Now we have one more called as frequency modulation, because I think comparison will become easy for you. High frequency carrier. So now what happened in frequency modulation, what we do is the frequency of carrier will vary as that of modulating signal, but the amplitude is going to remain same, because the frequency modulation what we are saying. Okay, now look at this here. The amplitude here is very high, here 0, so no change in frequency should occur. So let me build up that signal. The negative of cycle, no? So negative of cycle, it will be like this. Huh? No, look at this. I'll just put that clusters, I'll put it. So here, the frequency is high. The amplitude is high, frequency is high. Look at this region. Amplitude is minimum, negative. So here it will be like this part. Then again, frequency will become high. Look at the frequency of the wave carrier now will vary as that of amplitude of modulating signal. So what is this? This is a frequency modulated wave. So now this information. So how is information available? In the form of change in frequency. Information in the form of change in frequency of carrier wave. But amplitude is constant. Earlier, how much amplitude? Same thing. So information in the form of change in amplitude of information in the form of change in amplitude of carrier wave. Okay, this is called a frequency modulated wave. So you can question, sir, what is this? We are not understanding anything. Frequency here, amplitude 0. Okay, the frequency will be the same. So now as you move with the time, the amplitude increases. So the frequency of carrier will increase. Now again the amplitude decreases. So the change in carrier frequency actually should decrease. So somewhere it's 0. Again, you should have same frequency as that of carrier here. Now amplitude becomes negative. So the frequency will further decrease, the yellow color strip. The frequency starts decreasing. The frequency here in this region will become less than the original carrier frequency. So how this information is available in the form of change in frequency. Like that, we can bring several changes in carrier. This is not there for syllabus, just I introduced because some small discussion he has made in NCERT book. Better to have like this here. Okay, our syllabus is this one. Amplitude modulated wave. So we have to discuss this particular